Welcome. So in this video we're going to look at an example where we apply the second derivative test. Now that test says that if p is a critical number such that f prime of p is 0 and f prime prime of p, so the second derivative isn't 0, then f has a relative max at p if and only if its second derivative is negative, which means that the function at p is concave down. And we have a relative min at p if f prime prime of p is positive, in which case f is concave up at p. Note that the theorem doesn't say anything when f prime prime of p is 0, so it's inconclusive. We cannot say anything based on the second derivative test. However, in that case, we can study the sign of the second derivative to see if x equals p is an inflection point, that is a place where there's a change in curvature, or local extrema. We can also fall back on the first derivative test to see if there's a local extrema at p. So the problem we're going to look at is the following. Use the second derivative test to find the local extrema of the function f of x, which is 12x5 plus 15x4 minus 40x cubed. To apply the second derivative test, I will first need to find my critical values. And to do this, I need to find where f prime of x is equal to 0. So let's first start by computing f prime of x. So that's 12 times 5, 60 x4 plus 15 times 4, 60 x cubed minus 3 times 40, 120 x squared. Because I will need to solve f prime of x equals 0, I should factor this. There's a common coefficient of 60. I can also factor x squared. I'm left with x squared plus x minus 2. Can I factor this now? The first thing to try is to see if you can find two numbers such that their product is minus 2, sum is 1. If that doesn't work out, you can, at this point, use the quadratic formula and see if the polynomial can or cannot be factored. And if you can use the quadratic formula, if you can find two roots, you'll be able to use that to factor your polynomial. But it's easier to try first to find two numbers such that their product is minus 2, sum is 1. Can you find those two numbers? 2 and minus 1 will do. At this point, you could split your middle term, but because the coefficient in front of x squared is 1, we can immediately write down what the factorization is. So it's going to be x plus my first number times x plus my second number, and that second number is minus 1. So x plus minus 1 is x minus 1. Now we can write down what the critical values are. The critical values are what? They are the values that make f prime equal to 0. F prime will be equal to 0 if its factors are equal to 0. So that's if 60x squared is equal to 0. Well, that occurs if x equals 0. X plus 2 is equal to 0 if x is minus 2, and x minus 1 is 0 if x equals 1. Now, to apply the second derivative test, I will need to evaluate the second derivative at each of these values. So I will need to calculate f prime prime of x. I could use this to differentiate f prime, but that would involve some sort of product rule. It's easier to use the expanded form of the polynomial and differentiate each term. So 4 times 6, 240 x cubed plus 180 x squared minus 240 x. I don't need to factor f prime prime, but since I will need to evaluate it at each of the critical values, if I can factor it a bit, it's easier afterwards. So I can take out a 60, I can take out x, and I'm left with 4x squared plus 3x minus 4. And now I need to evaluate f prime prime at my critical values. Now, f prime prime of 0, if I plug in 0 here, it's 60 times 0 times minus 4, but that's going to be 0. f prime prime of minus 2. That's 60 times minus 2 minus 120 times what? 4 times minus 2 squared, so that's 4 times 4, 16, minus 6 minus 4. I don't need to evaluate this really. All I need to know is whether it's positive or negative. So this is a negative number and this is a positive number. So overall it's negative. And I can do the same with f prime prime at 1. It's 60 times 4 plus 3 minus 4. So 60 times a positive number. And that's positive. Now by the second derivative test, well, let's look at minus 2 first. X equals minus 2 is what? Is it a local max or a local min? Well, at minus 2, f prime prime is negative, which makes the function concave down, so it's a local max. At x equals 1, I have a local min because the function is concave up. And at x equals 0, the second derivative is 0, and the test is inconclusive in that case. We cannot conclude. It could be an inflection point, it could be a local max, a local min. We can't tell. So at x equals 0, the test is inconclusive. So how do we know what happens at 0? Do we stop there? Is there no way to tell? There is a way to tell. So at 0, what we can do is look at f prime prime and see if there's a change in curvature for f. So what I can do is study the sign of f prime prime. So let's write down f prime prime again. F prime prime of x is 60x times 4x squared plus 3x minus 4. Here I could look at the sign of f prime prime. Of course, I'm interested in what's going on near 0, and I will want to know what is the behavior of f. Is it concave up, concave down? Now, what's the sign of f prime prime? If you look at the bracket here, okay, this function's continuous. The 4x squared plus 3x minus 4. That's a polynomial of degree 2. It's a polynomial. It's continuous. So near 0, the function is getting closer and closer to minus 4. So near 0, the bracket is negative. So if I multiply that bracket by 60x, where x is over here, if x is negative, I'll be multiplying a negative by another negative. So overall, it's a positive here. On this side, x is positive, and the bracket, because we're close to 0 again, it's getting close to minus 4, so we have a negative number. So overall, here, the sign of f prime prime is negative. So what's the behavior of f? Here it's concave up, here it's concave down. And what do we get? We get that 0 is an inflection point. So we see that x equals 0 is an inflection point, and thanks for watching.